Welcome to Saxon Math Course 3, Lesson 111, Starred Problems. Now, the first starred problem in Lesson 111 is question number 4. Question number 4 asks us to add 3a plus 2b minus 5 plus 4a plus 5b minus 2. Now, what you're going to want to do is you're going to want to combine like terms by commuting them closer together. So we're going to want to put the ones with a's together, the ones with b's together, and the ones with no variables at all together. So we're going to have 3a plus 4a plus then the b's, so 2b plus 5b minus 5 minus 2. Now notice we keep the operation that is directly in front of whatever we're moving in front of that operation. So we got minus 5, we're going to continue to be subtracting 5. We're subtracting 2, we're going to continue to subtract 2. Now 3a plus 4a is 7a. 2b plus 5b is 7b, because 2 plus 5 is 7. And minus 5 minus 2 is minus 7. So that'll be question number 4. For question 6, we're asked to graph negative 4x plus 3y equals 24, and then also find when x is 12, what is y? Now, in order to do this, we're going to need to find the intercepts of the graph because this is in standard form. So we're going to plug in 0 for negative 4, which will give us 3y equals 24. If we divide both sides by 3, 3y divided by 3 is y, 24 divided by 3 is 8, which means when x is 0, y is 8. If we plug in 0 for y, 3 times 0 is 0, which will leave us with negative 4x equals 24. If we divide both sides here by negative 4, we'll get a negative because a positive divided by a negative is a negative, and 24 divided by 4 is 6. So our answer is negative 6 for x when y is 0. So then we just need to plot those points on our graph. So we're going to have 0, 8. So not moving left or right for the y-intercept. We're going to go up 1, 2, 3, 4, 5, 6, 7, 8. And we're going to go over to negative 6 without going up or down for our x-intercept. So we're going to go over 3, 6. And then we're just going to take a straight edge. And we're going to connect those dots. Now, in order to find what y would be when x was 12, we're going to plug in 12 for x. So negative 4 times 12. 4 times 12 is 48, so it's going to be negative 48. In order to find y, we're going to need to add 48 to both sides. That'll give us 3y on the left, and 24 plus 48 is going to be 72. And then we're going to need to divide both sides by 3. And 72 divided by 3 is going to be 24. So when x is 12, y is 24. Our next starred problem is question number 8. Question number 8 asks us to factor 36x squared y minus 24x y squared. So we're going to be factoring that out. Now, first off, we can see that both of them have an x and have a y. This first one has two x's, so if we take out an x from this and a y from this, all we'll be left with is an x. This one has just a y that will be left over. Because if we have xy times x, it'll give us x squared y. If we have xy times y, we'll get xy squared. Then we need to look for what's the biggest number that we can divide both 36 and 24 by. Now, I can see that 36 and 24 are both multiples of 12. this is 3 times 12 and 2 times 12. And if I take out the 12, I'll get 3 and 2. And there won't be anything else that I can take out. 3 and 2 don't have anything in common. They're both prime numbers. So that means I have 12 on the outside, 12xy. So that one way you can check your work is if you take 12xy and you multiply it by 3x. 3 times 12 is 36. X times x is x squared, and a y will be a y. 12 times 2 will be 24. X times nothing will be x, and y times y will be y squared. So remember that when you're factoring, it's the opposite of distributing it in, and you're just going to take out the largest thing you can possibly find out of it. Now, when I read question number 9, it made me laugh a little bit. It said, find the probability that an object that lands in the triangle will also land in the circle. Well, if I take my pencil and I put a dot in the triangle, there is no place inside the triangle that is not also inside the circle. This triangle is completely inside the circle. So if something lands in the triangle, it lands in the circle every time. And the probability for something that always happens is 1, or 100%. That's question number 9. Now, question number 12 asks us to graph y equals negative 1/16 x squared. Now, this one is coming from our investigation we just had about parabolas and quadratic equations, because we have an x to the power of 2. So what I'm going to do here is, I know that 16 is going to be divisible by, is going to divide multiples of 4 really evenly. So I'm going to use negative 8, negative 4, 0, 4, and 8 as the points that I'm going to use to graph. Because when I have negative 8 squared, 8 times 8 is 64. Negative 8 times negative 8 is also 64. So I'm going to have 1/16 of 64, but it's negative. Now, if I take a 16th of 64, that's negative 4. Now, if I have 4, 4 squared is 16, so there's going to be negative 16, or sorry, positive 16, because anything squared is positive. And then I'm going to have negative 1/16 of 16, well, that's negative 1. If I have 0 squared, 0 times 0 is 0, and negative 16 times 0 is 0. Now, if I have 4 instead of negative 4, it will still be 16 and negative 1. And if I had positive 8, it would still be positive 64 and negative 4. So what I'm going to have here is I'm going to have the point 0, 0, negative 4, negative 1, 4, negative 1, 8, negative 4, and negative 8, negative 4. Now, one thing that you should be able to see here is that there's a line going down through the middle where this is symmetrical on either side. Now, when you're going to graph this, I'm going to have to move the camera just a little bit. When you're going to graph this, you want the area near the apex to be almost flat. So when you're graphing this, you want to try and create this little curve here. Now, you want this to be a gradual change when you're graphing this, because this is not a very steep parabola. So you want to create a curve there, like that, and you want to kind of mimic that same curve on the right-hand side. You're not going for a straight line, you're going for a curve. And eventually, this will become almost straight as it's going negative, but that's much further out to the sides. When you have a fraction, like 1/16, next to your x to the second, you're going to have a more spread out graph. If this was a whole number or a large number, it would shrink down and become thinner. Now, this number will determine how wide and how thin your graph is. And since 1/16 is a very tiny fraction, it's going to be a fat graph. Now, since it's negative, it's going down. And that makes sense because the larger number you can put next to a negative, the further negative it'll go. Now, there's one more star problem. It's question number 12. Now, question 12 says, draw a line through the points 2, 5, and -3, -10. So I'm going to put the points 2, 1, 2, 3, 4, 5. This is 2, 5. And then I'm going to have -3, -10, there. And then we're going to draw a line that connects them. Oh, my straight edge moved a little bit there. There we go, much better. And now we've got a line that connects them. And then we're asked to write the equation in slope-intercept form. Now, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. The easiest one to find is where it has its y-intercept. That's over here at 0, -1. So the y-intercept is -1. The slope, you're going to take the closest point so that you can see where it crosses, and it looks like it crosses right here and right here. Now, it's going to rise up 1, 2, 3 boxes and run over 1. Now, if it's going over 1, up 3, it's going to be up 3, over 1, rise of 3, run of 1, and it's moving in a positive direction, so it's just positive 3 over 1, so that means 3 over 1. And we can simplify 3 over 1 to just 3. And plus -1 can be written as -1. And that is question 12. We've connected the dots. We found the intercept, we found the slope, and we wrote it in slope-intercept form. All right, this has been the starred problems for lesson 111. Stay safe, stay inside, wash your hands.